thanks so much. And before we jump in, I also just wanted to give a big thanks to our participating utilities and Incubate Energy Labs and this project, Ameren, who co-funded and hosted the project. Also Fortis and Tucson Electric Power, who follow closely along the way, Excel Energy as well. This project is really cool. And let me just introduce myself. I'm Annie Haas, and I'm the program co-lead for Incubate Energy Labs. And this project was so cool because it is really addressing one element of where the rubber meets the road when it comes to decarbonization, electrification of our end use of energy. And, and as Angie mentioned, the program is designed to pair utilities, startups, and EPRI subject matter experts in a really unique and collaborative way to conduct these demonstrations rapidly with the goal of scaling technologies that can help us address decarbonization, address electrification, address the commonly shared goals that all utilities have and in the industry as well. So I guess without further ado, really excited to introduce you to our participants, presenters today. Namit Singh, CEO of Microgrid Labs, and Travis Herman, who is now facilities manager for the Ameren headquarters, but was contract services manager during the time of this program at Ameren. These folks worked together and worked with a local school in St. Louis, and they're going to talk to you about this project. But without further ado, I'll turn it over to Travis and Namit. Guys, floor is yours.
Hey,
Travis, go ahead.
Hey, Namit. This is Travis. I figured I'd do a quick introduction and kind of talk about the utilities perspective on why this project was something that we were interested in working on. And really, when we were doing the evaluation of Namit software with Microgrid Labs, it was really a software that we saw as a all-encompassing that took in not only the wants of what in this case it was Hazelwood School District, but it also took in the needs and then the overall O&M expense that was happening with them with their current fleet and what their O&M expense would look like in a digital model. And so that was one thing that was really interesting that I was drawn to, is how detailed they got into what expenses were evaluated whenever they were completing their software. And I'm sure Namit's going to go through a detailed explanation of that as well. But it really takes a overall whole picture of what the cost will be associated with their current fleet, as well as the potential for an electrification fleet. And then it also gets a perspective of what Ameren's users. So we met with our Ameren distribution team, our Ameren solar team, the electrification as well, and then our billing team to make sure that we were getting a all-around picture of what the costs were associated with this. And being able to have all these different departments within Ameren really helped us focus on, what are we doing in order to help incentivize our customers, or not just incentivize, but, be a catalyst so that when we have potential fleet customers come to us and say, hey, we're interested in going from diesel to electric. We kind of, let's just say, ironed out some of the wrinkles that we've hit in the past. So just wanted to open up with that. Namit, sorry if I stole any of your thunder, but I'm sure you'll go through a good explanation of everything that we worked on.
No stealing of thunder. There's plenty to talk about. This was an awesome project to work with, and thanks, Travis, for the introduction. Annie, thanks for the introduction as well. So this has been a really good program because, again, we are coming from the technical side, focusing on the developing a technical solution for this market segment. So it was very good to closely work with EPRI and their subject matter experts, and at the same point in time working with Ameren to understand and see the utility side of of the equation, you may say, or their perspective as far as how they are looking at it, how they are approaching, what are the problems that a utility is facing, and be able to bring it back into our technology and support with that. So it has been great working with the EPRI team and definitely with the Ameren team. It was a very good experience. And as Travis mentioned that as and when we needed, they were able to pull in different teams within the utility. So distribution network, generation side, and all of that. So overall, great project even from our side, learning experience wise. And a quick shout out to two other utilities who were observers on this project, Excel Energy and Tucson Electric. They were also in pretty much all our meetings and discussions and providing feedback and input. So that was also really useful. So what I'll do is I'll jump right into our presentation. We've put together some overview of how we approach the project, what all did we look into in the project. And with that, I'll end this presentation and open for questions and communication. So really looking forward to that. So let's see if I can. Oh, perfect. So the big challenge and the need in the industry with fleet electrification. So we are a software and consulting company. We have developed the technology and the software around it, around this technology. So the reason we started focusing into this sector is that now with the fleets electrifying, our focus is medium and heavy duty vehicles. So with the fleets electrifying now, they are not responsible for just going out and buying the vehicle, but suddenly they are needed to make a decision on what is the battery size on my vehicle, what should be the power capacity and all those things on the vehicle. Then what is the charging infrastructure needed? What type of chargers? How many chargers? How do I operate those chargers? What type of electrical infrastructure upgrades do I need at my facility, and the impacts of that on the utility side? Then the energy infrastructure as well. Can I generate my own electricity, store my own electricity? How do I do all of that in such a way that my overall cost of operations stays the same or goes down as the big promise of electric vehicles is? The big challenge is that all of these pieces and each of this has so many other sub bullets, so to say, that all of these factors are intertwined and dependent on each other, that you cannot just focus on one and make a decision and not worry about everything else. You have to look at the whole equation. You have to look at the whole system and optimize it across the whole system in order to come up with the best solutions. So that is what we have done in our software platform, that looking at all these models and creating physics-based detailed models for each and every one of this in such a way that when you build a project or work on a project, you are taking everything into consideration. And the idea is that by doing all of these things up front in the planning phase, you know exactly what you're getting into. You know very closely what is the cost associated with each and every one of those, and the performance that the fleet is expected to deliver. And with all of those things put in together, you can make a decision upfront in the planning phase before you invest any time or money in it. So the approach here is that we start with the fleet, looking into the routes they are operating, looking into all the details associated with the routes, that where are they operating it, how are they operating it, what type of payload, so weight wise, what type of payload are they carrying, how many stops they are doing, the detail of duty cycles, what is the route or the terrain on which they are operating, weather conditions, because as you guys might have heard or know by now, that the way an electric vehicle operates is very sensitive to the weather outside as well. So all of these factors we have brought in and build a physics-based model around it, so that when you are looking at buying a fleet vehicle, you are not looking at a very high level and doing a a general study, but specifically to your route and to your fleet. So that level of route analysis we do. Based on that, we come up with battery sizing or the vehicle requirements for each and every vehicle operating on each and every route. And moving forward, the details of charging infrastructure, and we'll get into details as we move along. And then looking at energy infrastructure, that what will be the impact on the grid? Can you mitigate those impact by either controlled charging or generation or storage or mix of all of those things put in together? And of course, financial planning around it. So perfect. So in this project, the idea was to use our software, work with the utility and understand that aspect, and work with Hazelwood School District to do a detailed feasibility study. And with that, come up with a zero emission fleet transition plan and build the digital twin for the depot so that that can be tied in with the utility softwares or other programs that the utility may have. So that part is ongoing, but all the other things were completed here. So the first aspect, the route energy analysis, the approach here was we worked with, luckily, Hazelwood School District has a telematic provider. So there are data loggers installed on their vehicles. So we gathered that data, did some pre-processing on the data. Based on that, came up with models of how the whole, starting with each and every vehicle and each and every route, able to build up how the whole fleet is operating in today's date. And I'm talking about the diesel fleet right now. And with that, be able to create the digital model of their complete route and how the fleet is operating. And next step from that was looking at the terrain and weather and everything of that sort, and come up with what will be the energy required if you were to operate an electric bus on that route in that exact same fashion. So one assumption that we make is that you are not making any changes to your existing operations, but the electric fleet is supposed to serve the same operations. So we gathered the data for, they have 120 buses. So with that, the data loggers, we were able to get data for 2 different months. So this was pre-COVID operations, because during COVID, the fleet was not operating as usual, and post-COVID operations. And based on that, we looked at about 26 million data points and did the analysis based on that. So here is just a sample that this is 1 day's operation for one bus. So on the x-axis is time and on the y-axis is speed. This is their duty cycle. So we are able to track and sense that how the fleet is operating on a per second, or in some instances every 5 second or 6 second, however the data logger is capturing the data. So here you can see we are able to observe that how the vehicle is moving, braking, stopping, slowing down, and all of those things, because all this goes into the physics-based model. And wherever the speed is 0, we know that this is when for this much amount of time the vehicle is parked somewhere, or when we are looking at charging infrastructure analysis, we do that type of analysis, that if it is stopped or parked, then where is it parked? So can we incorporate, if need be, on route charging infrastructure and all of those things. So we try to get the data, 1 second data, operational data for every single vehicle for the whole fleet. And that is the level of analysis we do. The other way to look at it is that if you do not have loggers installed, then we also have data loggers that we can provide and loan out in order to get short-term data to start this analysis and work on this analysis. But in this case, luckily we had the fleet which had all the data available. So with that duty cycle available, we plot it or have the duty cycle for every single day, every single route, in the same way as I was saying earlier, that the way electric vehicle operates is very sensitive to temperature and the terrain on which it operates. So we take all of these into consideration, that on that particular day, how was the weather? Is it cold weather, hot weather? Do they need to turn on air conditioner, heating, and all of those things? So these are the level of details that are built into our software, that all this data goes in as input, and based on that, the software is able to do route modeling. So here is an example of the GPS trace, that every second data that I was talking about, that this is what is available now. This is I'm showing on the graph for one bus, for one route, for one bus. This way we analyze 2,800 bus days, and based on that we know exactly where each of these fleet is operating. So moving forward, when we do charging location analysis and things of that sort, so then we can look at a bigger picture. So this is one day, one route, and in that same fashion we are able to get this type of layout for the whole fleet, and for as much data as we have available. So in this case we are looking at 1 month worth of data, but if you have the whole year, then we can look at that and exactly identify that what is needed. So based on that, here is a very simple output, that how is the fleet operating. So on the y-axis we have the distance. So we know that most of the fleet vehicles that we are looking at operate less than 200 miles in the course of a day. There are some that go above that, and most of them are less than 150 if you look at it that way. So this is the type of output that we get, and then with that, then we start looking into the energy consumption, that now if we have to operate electric vehicles on this route, then how will it operate? So that gives us a good idea of, when you are looking at the whole fleet, what is the energy required for each route, each bus, for each day's operation. So the same graph that I'm showing here, then we structure it in such a way that we are able to see that one question that comes up is my fleet electrifiable? And if I electrify, then how much? So based on studying all the routes for the course of 1 month, we can clearly see that for the electric buses, school buses available in the market in today's date for the battery capacity, about 80% of the routes can be electrified in today's date and can be served in today's date. So again, you are talking about a fleet of more than 120, so they will not go or switch on day one. It will be gradual, but this gives them an idea of if I buy 10, 20, 50 electric buses, how many routes will I be able to serve? So with that, now this is the month of February from pre-COVID operations. So with that, then we are able to identify and look into the worst day as far as the energy consumption for the whole fleet. So out of that, we identify that. So this would be the worst day of operation for an electric fleet, and do a detailed analysis for every single vehicle that operates on that particular day. So if you have 1 year's worth of data, so we can analyze the whole thing, and based on that, look at the worst case scenario, look at the 80% scenario, 75, 50%, or whatever you may be interested in. But the idea is that this gives you data based on the input that is coming in. This gives you data based on which you can clearly understand that this is how my fleet is operating, and based on that, make decisions. So with all of that being the first part, the route analysis, the next is the charging infrastructure analysis. So this is where, again, phasing of the project also comes into picture. So we talked to these guys that, as I mentioned, 120 buses, they are not going to electrify on day one. The idea is to do 10 or 15 first, then the next phase, then the next phase, and then the next phase. So the idea was that now, in order to, if the example shown here is 15 bus. So if you are doing 15 bus EV charging, so then what type of chargers are needed? How many chargers are needed? Will the existing transformer be able to support it? Do we need upgrade on the transformer? And then going upstream. So now if you change the transformer, can the medium voltage feeder, in this case it's a 12 kV feeder, can the medium voltage feeder support it? That's where what Travis mentioned earlier, we had meetings with the Ameren distribution team to understand that what is the load profile that particular feeder is supporting. will that be able to support the load profile coming out of this case? So here we are talking about phase one, but moving forward in the same fashion, we look at the next phase where looking at adding another 50 buses. So then here, just as an example, so this is a full EV fleet, right? So this is the end goal where the fleet is trying to get to. So we looked at multiple scenarios, multiple design options, multiple approaches. So I'm just showcasing and discussing one over here. But the idea is that in order to go through this, what would be the phasing or the stepwise approach for your charging infrastructure purchase and construction? Based on that, the electrical upgrades, based on that, as I was saying earlier, what will be the impact on the medium voltage feeder? So that's where we worked with Ameren to understand that what is the load profile on the feeder. Will the feeder be able to support this now, 2 years from now, 5 years from now, 10 years from now? So that phasing is helpful for the fleet to make decisions as far as purchase is concerned. But at the same point in time, it is important for the utility to understand that, okay, now I probably don't need to upgrade or change the transformer for your first phase of project for 10 buses. But the moment you're talking about the next 30, that's when I need to upgrade and maybe potentially the feeder when you talk about 120. I'm just talking about some examples here. But the idea is that this level of detailed study provides information for the fleet, for the utility, for anyone that is investing, or these guys going out for grants and things like that. So the idea of building a software platform where now you start doing this analysis, you have all of this phasing built into it, and these models are then shared across. So the software is available on the cloud. So the idea is that the models can be shared. So let's say if the fleet starts and does the first level of high level analysis that this is my fleet operations and builds the model there, and then a consultant needs to come in and do detailed electrical design. So they don't have to start from scratch, but here is a platform where everyone is working together and building on top of each other. So once the electrical design is there, then the utility can go in and look at it. Then the investor can go in and make investment decisions or whatever it may be. But the idea is we have a cloud-based platform where you can start building the model. And then 2 years down the line, when you want to go and modify it, you don't have to start from scratch. The model is available. You just keep modifying and keep building on top of it. So the other analysis that we did was solar. That can you have on-site generation? Is the fleet interested in doing on-site generation? So looking at doing carport at all of these locations, understanding that what will be the load profile or energy cost associated with that, and build based on it. So here is one model and example that I'm showing, that if they are able to cover the whole parking lot and the employee parking with bus port and carport solar, so you are generating energy. There are other benefits as well in some of the states and locations. I live in Colorado. Unfortunately, here the school buses cannot buy insurance against hail. So you have to come up with your own hail insurance or provision. So bus port or carport solar is perfect from that aspect as well, just as an example. But the idea is that with all of these things, you are able to generate energy, store energy. So maybe the school district owns it, maybe the utility owns it. So it doesn't matter who owns it and operates it, but the idea is that here is a consumer with high energy and power demand. So you can have on-site generation and space available for that. So in this graph, let me go to the next slide. That's where we are. Okay, I'll come back to that later. But here is one level or one scenario that we are discussing, that they install 115 kilowatt AC chargers. So if that is the scenario, then what is the load profile associated with it? What is the upgrade cost associated with it? What is the phasing associated with that? So that level of detail we go in here. And again, this is where working closely with the utility and understanding that what are they looking at, right? And how can the project support the utility as well. So here we analyze that if you, whatever load profile you have throughout the course of a year, can the feeder support that during summer months when the air conditioning load is really high? The use case here is good that school buses do not operate at full capacity or do not operate at all in some cases during summer. So that means you don't need charging. So you can design based on that. But the flip side of it is that now, what about vehicle to grid? Everyone is talking about V2G as well. So now, if you want to use this fleet in order to support that particular feeder, then the design completely changes. Then you are not talking about just AC chargers. Then you would have DC chargers, your cable capacities, your feeder capacities locally here, the feeder supporting the chargers. So the sizing of all of that changes. So the infrastructure completely changes just to support that particular use case. But the idea is that does the utility need it? So these are the kind of discussions we went through with the utilities to come up with resiliency options that can you actually buy V2G, because if the vehicle battery is 200 kilowatt hours and we are talking about 100 of these vehicles, then you are suddenly talking about a 20 megawatt hour battery. So is there any use for it for the utility? That is what was discussed. And then the idea was, excuse me. And the idea was, if yes, then for this battery, what is the power do you need? Do you need a 1 hour support? Do you need 4 hour support, 10 hour support, whatever it may be? But anyways, that is the level of detail we went into when we were discussing the charging infrastructure and looking at all of these different scenarios.
Namit, I'm sorry to interrupt, but I think there's two questions in the chat that it may actually feed into what you were just talking about pretty well. One is about, does the tool help prescribe or recommend which EV model to buy in addition to the battery? And then the second one on utility, upstream impacts. Are you assuming circuit optimization or simply the total demand from each charger added together?
Okay, I'll separate the I'll answer the second question in upcoming slides, because we talk about what we've done on that aspect. But the first, actually it's the other way around. So the vehicle model. So we are building these vehicle models as these are being released in the industry. So right now focused on medium and heavy duty, as I said. So this use case talking about school buses, right? So there are 3 or 4 manufacturers, each one of them having multiple models of battery size that is available. So the way we are doing it is we are creating digital models of each and every one of this with as close as possible the physics-based model into the software, so that whoever is operating it, using it, running it, can probably go through a drag down menu and based on that select that how will this perform on my route, how will this perform on my route. But for that we need very detailed inputs coming in from the OEMs as well. So at this point in time we have generic models created and then validated by us, and also we've worked closely with the NREL, National Renewable Energy Lab. So they have also validated that in several scenarios, the accuracy of that physics-based model. So the idea is that as the industry grows and as we move forward, we will keep adding these and building these models by working with OEMs. But at this point in time, we have a very accurate generic model that we have used here. So that's what will help make a decision as far as the vehicle is concerned. The grid aspect, I'll come to in the next slide. Let me quickly go through this. Another few scenarios that we looked into here was unmanaged charging was one. So first, at the design phase itself, we are able to reduce the peak demand by making sure that the charging infrastructure is as needed and optimized, and hence able to get it down to 1375 kilowatt in this case. And with that, the existing tariff structure for the utility, with that they come up with the approximate operating cost during the winter months of about 12,600. And if we are able to further reduce it down, so it goes two ways. One is, of course, the direct savings for the fleet, but then also working with the utility to make sure that there is grid constraints or those can be brought into picture. So here we assume that the lowest that we can bring it down is 1 megawatt. So with that, there are benefits to the user as well. And along the same line, then the next one was that if you now generate and store energy and use that, that's a separate scenario that we looked into. So these are all these things we can actually model using the software. The idea is that you shouldn't have to go and implement the project and then start all of these things. So at the bottom, I'm talking about in the same existing operating scenario, if we do tariff optimized charging, or in this scenario, looking at a completely different tariff structure. If the same profile was in a different tariff structure, so for a 2000 or 2 megawatt load, the electricity bill would have been 38,000 per month, as compared to, in this case, this tariff structure, it is 12.6K. So that is a good tariff structure for this fleet, for this operations. In the same way, if you look at it for that other tariff structure that we analyzed, so there the reduction in demand makes a huge difference. So from 2 megawatt to 1 megawatt, if you are able to bring it down, then your operating cost comes down from 38K to 19K, which is a huge delta as compared to in this tariff structure. It's not that big of a change, but still it's reduction. So anyways, the idea is that looking at all the scenarios and working with the utility, building their scenarios in here, we are able to design and come up with the best scenario for the fleet, and also what is the best for the utility. So now here, another use case, I'm just quickly going to go through this, that school buses, they are parked during the middle of the day. In the morning, they go drop the kids, come back, and they are parked, and then again go in the afternoon. So now, rather than doing all the charging at night, if we are able to do the charging in the middle of the day, so that can reduce your operating cost further. But at the same point in time, now you are at the feeder level, not just at the site level, but at the feeder level. By charging in the middle of the day, you are able to consume and use the belly of the duck curve, or use the energy that is solar-based energy that is generated on the feeder or in the grid in general. So again, another scenario, but the idea is that all of these things can be done in the planning phase itself. So with that, then the next step that comes up for us, and I'll keep this very quick, is this is all planning and initial phase of the project. But what happens when the project is actually implemented and the vehicles are actually operating? So that is where we have an operational controller, or what is known as charge management system, with a lot more features built into it. So a depot management system, which is, again, the key is it's not just saying that, hey, don't charge at this point in time, but it is taking all the inputs into consideration, what we talked about earlier, and looking at the whole system. So how the vehicle is operating, interacting with the vehicle in real time, how the chargers are operating, how the building load is operating, how the utility is operating. Can it support all of these charging or not? So looking at all of those things in one equation, and looking at it at a system level, and constantly optimizing the operations. That is what the EVOpt controller, which comes in and which is the next phase of the project that we are exploring, is able to do for the utility. So we have that also up and running. Here is a real world example, just as an example to show you the grid load on the left side. So this line is grid load. So if we get a signal from the grid, and this is something which we are able to in real time integrate with the grid software, or working with the utility, that if the utility is able to send signal to us that, hey, at this point in time, I am not able to support charging, so I want your charging at this location to reduce. So the controller is able to optimize and make decisions on that front, and hence reduce the charging profile. So this corresponds to top right is what is going on the charger side, what is going on the vehicle side. So again, as I said, that we are looking at it at a system level and able to in real time interact with the grid, work with the grid to make decisions, not just hey let's reduce peak load shaving, but we are able to shape form what the utility needs and the requirement on their side. So this has been, we've partnered with Itron, because Itron is one of the leaders in your distribution network related hardware and software. So we have partnered with Itron and completed our first integration with them, so that Itron is able to provide all the information on the distribution network side, and we are able to provide information and control everything behind the meter. So jointly, we are implementing this solution, or we finished our integration with Itron. But the idea is that if your utility is already working with Itron, then we can move forward faster. But at the same point in time, the idea is we'd like to work with utilities to tie in so that we can support you in real-time operations as well. The other aspect, a little different, very quickly going to talk about this, is a multi-level controller, which comes into picture when we talk about residential level. So the approach is different, the architecture is different of the software, but the idea is that as we move forward and we get more and more EVs added to at the residential level, so that is where this controller comes in and able to support the grid as well. So the moment all the houses start getting EVs, your distribution transformer will basically overload and hence moving forward on the other level as well. But the idea is to be able to control it and provide that at the residential or the lowest at the charger level. So another aspect that we are working on. So quickly, as a company, we are a startup. We started this program at that time. We started looking for funding as well. So just December, we closed our first round of funding with Innosphere Ventures locally here in Colorado, and Catalyze and Jacobs as our strategic partners, with Catalyze being on the solar and storage side, and Jacobs, everyone knows, is one of the largest engineering companies around the world. So with this team, now we are able to support the industry and in providing a turnkey solution that MGL and the technology that we have built is able to do upfront work, and then Jacobs and Catalyze with their expertise and experience comes in, and we are able to implement project, operate project, bring in funding into the projects as well. So very strategic partnership here, and very excited to for this opportunity to partner with everyone and be able to provide support to the industry, where we can support everything from start to end. So anyways, that's I'll stop right there. Really, again, want to thank everyone on the utility side, Ameren, Excel, and Tucson Electric that worked very closely and helped us in shaping some parts of our solution, and of course EPRI for everything that they've supported us with. So I'll stop right there. But again, back, I think there was another question. Does this answer my discussion about how we have integrated in with the utility distribution network in real time? Hopefully that answers the question, but I'm gonna give it back and open it up for discussions, and definitely we can connect offline for detailed discussions. Thank you again, everyone.
Namit, thank you so much. That was great. And
Absolutely.
this was such a cool project, because it's really kind of looking at this last mile of electrification. It's looking at, on the Ameren side, they engaged the Hazelwood School District down in St. Louis.
Yeah.
And that was a pretty interesting process in and of itself. And surprising to, I guess, just get the level of excitement from their team and their superintendent. And I think the whole team really learned a lot. But I don't know, there was one more question. I don't know if you addressed it, Namit.
Let me go back and see.
Around could the model also take into consideration regulation services or modulated charging rates to address demand charge concerns?
Yes, yes, and those can be built into the software or modified or tweaked, but we actually input and build very specific utility related information. So whatever information is there, that's what we are able to build into the system.
Thanks for that. Well, opening it up to the group on the line today, are there questions for Travis, Namit, or any of other utilities? Liz Hunt is on from Fortis. She's also on the electrification side of Fortis's operation, and might be interesting to kind of open it up for some feedback from our utilities on the line around kind of the potential implications for this type of work. And maybe we start with Travis in that regard. Coming out of this demonstration, and I know that you guys are still talking with Hazelwood, do you have an idea of the next steps for the district and what they may be planning on doing with their transportation fleet now that we've gotten through a good part of this study?
Yeah, so so what they're going to be doing is utilizing this for some of the federal grants that are going to be coming up. So kind of the idea behind it is if you have a feasibility study completed and in place, whenever the grant money is being distributed, they should have a little bit more advanced proposal to go ahead and receive some of that funding. So that's really what they're going to be utilizing it for. Is that cover it, Annie? Sorry, that's kind of a short response.
Oh yeah, no, that does. What I mean, do you anticipate with some of your other customers, Travis, that there is, and maybe Liz could address this too, this type of a approach, do you guys see that there is an active sort of audience for this within your customer base?
Yeah, so one of the departments within Ameren is the electric feasibility department, or not feasibility, but now I'm drawing a blank on their title. But basically, they're responsible for trying to go out into the community and find different fleets that fit kind of our size and criteria, and work with them on coming up with plans on being able to transition. And luckily, we're working with Namit and Jonathan on this project. Actually set them up with Ken Cressman, and it sounds like they're moving forward, trying to evaluate some other projects in the St. Louis area as a potential, and seeing how it lines up. So really, it helped us be able to, like I said in the beginning, it's really just trying to eliminate any roadblocks, make it as easy as possible for the customer, and really show the incentive of why we're wanting to move from diesel to electric. And working with Microgrid Labs definitely helped our internal team add some tools to our toolbox, so that when we do approach our external our customers, we have experience in helping them transition to a electric fleet.
Yeah, and just to add one more thing on that line, now with the infrastructure law, the funding coming in on the transit side, they have already specified that if you want any money from this funding, you need to submit a zero emission transition plan. So that is a mandatory, or maybe it's not out there finalized, but that's the direction in which it's going. That will be a prerequisite, that with your application for funding, it's not just going to be high level that, hey, you have money, give it to me. But it will be, you need to submit a zero emission transition plan. And we anticipate the same thing moving forward with other sectors as well.
Well, that's huge, right? I mean, just in terms of a tool like this and other technologies out there, in terms of being able to understand those potential impacts is a big deal. So
and what we feel is, another thing is that this transition is not going to happen in one go or one step, right? This will potentially happen over the next 10 years or something. So these fleets will have to go back and refine it, keep working on it, making changes. So that's where again we feel like a software like this. So you can't go and hire a consultant every few years to do it. So the idea is you build it once and you keep modifying it, right? So that's the intent, that with a software like this. And also, briefly I mentioned that you can actually share with other stakeholders as well. So the fleet starts it, builds the model, shares it with a consultant to work on details, and then they share it with the utility. So now it's not like you're not just sharing a paper report, but an actual model where anyone can go in and work on it and build on top of it. So that's the idea of building bringing a software planning software with this level of detail.
Namit, when you guys get additional information from like the EV manufacturers and others in terms of their models and things available on the market, and are you guys pushing those out so that folks that subscribe to the model automatically get those updates in terms of additional data sets being added to the model, or doesn't work like that?
So it's anticipated, that's in the roadmap. So right now we have been again we started off with NSF funding, National Science Foundation, and the funding was limited, and there were only limited, very technical, innovative things that we could do with that funding. So the idea of that funding is to develop cutting edge technology and be focused on technology that does not exist. But these kind of things were not supported by that funding. So now that we have closed our first round just a couple of months ago, so we are cleaning up and coming up with these roadmaps, and that is where we are tying in through APIs and other things, and we'll work with the OEMs on the charger side as well as the vehicle side, so that we tie in the APIs in such a way that whatever updates they do on their side, either they can push it to the system or however the approach is. But the idea is that we should be able to maintain updated database on all of that. So moving forward, that's the idea.
In terms of next steps and kind of scalability, I'm curious, kind of from your perspective, what are your next steps, and how do you plan to market this technology?
Yeah, so thanks, Liz, for that question. It it is a whole discussion, but the two key products, as I mentioned, that planner is one and the controller is one, right? So the track for both of this is a little different, but at the same point in time, the idea is at this point in time in the industry, detailed planning is what is needed. And again, with this infrastructure money coming in, there will be a push to expedite these things and move it forward. So the idea is to offer this software to every single fleet operator so that they can do this analysis themselves. So they are experts at transportation and operating their fleet, but they are not experts in electricity and everything else. So let them take care of their part and build the model, and then everyone else builds on top of it. So the idea is that the fleets and everyone that is going through the transition should be able to use the planner and really come up with detailed technical as well as financial feasibility study. And then moving forward, once the projects get implemented, that's where the controller comes in, and these two are tied in very closely when you are looking at optimizing the overall system and how you operate it. But when you're operating the fleet, the idea is that it is tied in with the utility, with of course the fleet operator gets all the information, everything at one platform. But the way we look at it is like you have NOC, the operating centers in utilities. So the fleet operator will have the same, where they can see the whole, and we can show the demonstration. They can see their whole fleet operating and each and every vehicle related information. But anyways, long answer, but the idea is that there is one product which supports the planning and the transition, and the other product which basically grows as the market grows. So we are looking at and talking about all the fleets. So initially focused on transit fleets, now school fleets, and now talking to commercial trucks and the last mile connectivity. So basically within the next 8 to 10 years, all the fleets, everything really need to convert. So the idea is to support with these two products.
Thank you, Nimit.
Does that answer some part of it? Sorry,
It does.
I
Thank
went on
you.
a little tangents there, but
Thank you.
sure.
Other questions from the group on the line today? Any questions from our EPRI folks on the line?
Annie, can you hear me?
I can.
Yeah.
Namit, thank you very much. It's Edward Kerr speaking. So I had a couple of questions. One is, I know the focus on this was fleet management, but your residential controller piqued my interest big time there at the end. So, I could see munis and co-ops being really interested in that product.
Right.
Or that software capability. So that could be for a further discussion. I don't want to sort of sidetrack this conversation, but you just sent something here just a few minutes ago talking about the planner. I'm assuming the planner is in essence like a TCO tool to help a fleet sort of figure out what it's going to take to do this transition from petroleum to electrification. Is that correct?
So you can look at it that way. That is, the TCO is one output that comes out of it, right? But then because of course, like basically everything comes down to money, right? So what is the amount of money required? Why should I do it? Can I get investment and all of those things? So that is one part of it and one module of it, one outcome that comes out of it. But the other aspect of it is to be able to really see that what is starting from the vehicle side, that which vehicle should I buy, what should be my battery size, and not really get surprises the way fleets have been getting that, oh, you said your bus will operate 100 miles, now it's just doing 40 or even 50 or something close to that. So the idea is that all these things are so new that the transit, you don't expect the transits to be an experts in all of this. So this would really be able to walk them through and give an idea of what are they getting into. So what will the vehicle, how will the vehicle behave, operate, how will your charges behave, operate, how will your cost change associated with all of those things. So kind of a high level design will be presented as well, and not just that, oh, you go from diesel to electric, you'll have 30% savings or 50% savings. So that is TCO is detailed one part of the output, but there are a lot of other aspects, and then there is some optimization that is built into it that, as I was saying earlier, the moment you look at the whole system, you can bring in lots of optimizations and other aspects as well.
Sure. So I guess, a question that I would have then is that if part of the planner is a vehicle to help recommend, a particular vehicle choice for the potential fleet operator, is there not some risk around indemnification or liability, in terms of what you're saying the vehicle will do versus what the vehicle actually does? I mean, how do you handle something like that?
That's exactly the point. What I said earlier to Annie's question, that we moving forward. So right now we have created generic models that this is a 40-foot transit bus. If you operate that, then this is how it'll operate. So in the back end, we have modeled it for a particular OEM, but we cannot, because we did not work with that OEM, so we cannot say that, hey, this is a Bluebird bus or whatever, right? So exactly that. But the idea is moving forward that if the OEMs really get the idea of what we are trying to do here, So then we would be able to work with them and then validate these numbers. And again, I briefly mentioned that we validated the physics-based models with NREL, and then by comparing with real-world operations of EVs. So on our side, we have done a lot to, and of course, constantly moving forward, doing things to validate and make sure that it's as close to operating scenario as possible. But moving forward, we are looking at other ways of building it in such a way that if the OEMs agree, then we build models and name it that this is that particular bus.
Yeah, sure. So are you prepared to, a lot of utilities are finding in this space, in this sort of medium heavy duty space, that the fleets need a lot of hand holding. Yep. They don't know what they don't know. And the utility, that's a natural role for the utilities to fulfill as sort of, the trusted energy advisor. So could you see some of your offerings here sort of being white labeled and, residing on utility websites, but you would operate all of the background around the modeling capability?
Absolutely. And that is some ongoing discussions, and totally agree with that. That's the white labeling is one solution. The other thing on top of that, and totally agree with the hand holding. There is a lot that needs right now. That's why we still do consulting, and we will keep doing it. But the idea is that by working with the utility, you can white label the solution, you can offer it to your customers, and that way, in today's date, from what we've heard from utilities, is they don't even know what fleets are operating because they never cared that are you just a building, or are you building plus 20 vehicles or 50 vehicles, right? So this gives the utility an avenue that by offering this to all the fleets, they can do this high level analysis, and that way the utility will find out, okay, I can probably expect a small depot coming up here and a here and here. Yeah, sure. So that is one. Absolutely, white labeling is one of our business models that we are looking at. And what we offer as any membership is some number of training hours and some number of, we don't want to call it modeling hours, but basically support and hand-holding hours. So if we go through the utility with the white label solution, we would most likely offer the same thing. That if you have any new members that are interested, then we will have some sort of training associated with that.
Okay, great, thanks.
Well, we are closing in on the end of our session today. I just put Namit's email into the chat. If you had additional questions for Microgrid Labs about this project or about where they're going from here, or anything else for that matter, feel free to reach out to them, to Namit directly. And I just wanted to thank everybody for joining us today. Hope folks have a great rest of your week, and feel free to follow Incubate Energy Labs at labs.incubateenergy.org. The final report from this project will be available soon, and there are reports from all of our projects on that website on the past projects tab. So feel free to check it out, and hope you can join us for another episode next month. And until then, thank you so much. Thanks to our panel today, and hope everybody has a great day.
Thank you. Thanks everyone. And feel free to reach out through our website or LinkedIn or email, anything. Even if you want just to chit chat and brainstorm about things, absolutely open to that and look forward to it. Thanks, Annie. Thanks, Travis.
Thank you. Have a great day, everybody.